remember, we're talking about elements, compounds, and mixtures. They are different things. They can be the same materials, but they're different things. So we're going to ask the question, what are elements? What is an element? An element are any pure substances that cannot be separated into simpler substances. So I'm sure you all know the periodic table, Chumai. Everyone see this before? Yes or no? If you've seen this before, say yes.
Yes.
Yes. Hit, Kuming, have you seen this before? Have you seen this one, this periodic table? No? Yes?
No.
No? By core, have you seen this before?
No. No.
Okay. What this is all the atoms, all the different atoms in the universe that we know exist. They're all the different atoms in the universe. So if I go through here, for example, you can see H, morning Azim, you can see H. H is hydrogen, then helium here, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, magnesium, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, krypton, etc., etc. Yes, all of these make up everything in our universe. And if you just want to know what the rest are, I'll very quickly tell you. Rubidium, ceruleum, deuterium, cerium, nebidium, molybdenum, tachyon, rubidium, rhodium, palladium, gold, Ag is gold, Cd is cadmium, iodine, selenium, rubidium, beryllium, iodine, xenon, cesium, beryllium, is it beryllium? Beryllium, yes. Lanthanum, hafnium, titanium. This one is mercury. W is mercury. Rhodium, osmium, iridium, platinum, gold. Sorry, this is gold, that's silver. Hg is mercury. Mercury, Hg is mercury. Titanium, Pb is lead. Bismuth, polonium, atomium, I believe, and radon. These are all gases, by the way, and these are all solid. These are all gases too, all kinds of gases and solids. So all of these different substances make up, all of these different elements make up the universe. Everything is made of these atoms, and they are pure. I cannot separate hydrogen from hydrogen. I mean, yes, I can put hydrogen in two separate places, but I can't separate them. There's nothing to separate. It's just hydrogen, just hydrogen. Okay. And that's how they kind of look. By the way, they generally go from metals to gases. So when we get to helium, neon, argon, krypton, and xenon, these are pure gases. These are pure gases. The rest are kind of metals. We have some liquids, but most of these are going to be metals. But they all exist in the periodic table. So all of those elements you see here are all pure. They can be pure gas, pure liquid, or pure solid. By the way, does anybody know which one of these, well, there's actually two, but which one is easiest? Which one of these is a liquid metal? Which one of these is a liquid metal? Does anyone know?
Mercury.
Say again?
Mercury.
Mercury, you're absolutely right, Azim. Mercury is a liquid metal. At room temperature, liquid is a liquid metal. Do you, by the way, Azim, do you know the other liquid metal? There's two, actually.
Gallium.
My goodness, you're absolutely right. Well done. Very, very good. That's amazing. Yeah, very good. Well done. Yeah, there are two liquid metals. And the one you would all know is mercury. It's that shiny metal that moves around an awful lot. But anyway, all the elements we have and all the elements we know are pure. They're pure, and we don't need to separate them. Well, usually we don't need to separate them. So what are compounds then? We know what elements are, but what are compounds? So substances composed of two different elements together, joined by chemical bonds. Now, don't worry about chemical bonds, but basically, hello. If I take hydrogen and oxygen, Pamuk, if I take hydrogen and oxygen and I put them together, I've taken pure hydrogen, pure oxygen, I put it together, I've now made what? What do you think I've made?
Water. H2O. Water.
H2O, yes. I've made hydrogen. I've made hydrogen and oxygen. Who's got their shampoo? You had your thing on. I've taken hydrogen and oxygen and put them together, and I've made water. I've made water. If I take pure sodium, Na, and I take pure chlorine, Cl, and I put it together, I've made sodium chloride. Sodium chloride. So here I took pure hydrogen. Here I took pure oxygen to make water. Here I take pure sodium, and here I take pure chlorine to make sodium chloride, salt. And here I've taken pure carbon, I've taken pure oxygen to make carbon dioxide. So compounds are when I take two different elements. Remember, these are elements. All of these are elements. When I take two or more, I've lost it. When I take two or more of these pure elements and put them together to make a compound, So let's be clear. To make a compound, I take pure elements and put them together. To make a compound, I take pure elements, Kuming, and put them together. Okay? Everyone clear? Yep. So that's a compound. And I can separate them only by chemical means. So it's not like I can take hydrogen and oxygen. I cannot take hydrogen, oxygen, water. I cannot take water and use my fingers or some device to separate it. I must separate it using some other chemical. I cannot separate sodium chloride with my hands. To make it go back to pure sodium and to make it go back to pure chlorine, I have to use a chemical method, not a physical method. So compounds have to be separated chemically, not physically. By core, you understand?
Yes.
Okay, so compounds are made of pure elements, but those pure elements in compounds I can only separate back to pure elements chemically. I cannot do it physically. I can't take a hammer, I cannot break it, I cannot separate it. I must use another chemical to make it separate. And here's some examples of compounds: water, carbon dioxide, methane, ammonia. All of those have pure substances. Look, pure elements: oxygen, carbon, carbon, hydrogen, nitrogen, hydrogen, oxygen, and hydrogen. Those are pure elements that come together to make compounds. So compounds are made from separate elements that come together to make a compound. Okay, so what happens, for example, when I combine sodium and chlorine? Here you can see the sodium is a solid, but the chlorine here is a gas. It's actually a gas inside there, and it looks like a liquid, but it's actually a gas. You can have chlorine liquid, that's possible, different type, but in this case it's a gas. when I put sodium, a solid, and chlorine with my gas, what do I get? I get salt, sodium chloride, salt, sodium chloride. So in that case, we know what elements are, we know what mixtures are, we know what compounds are. So what is a mixture? Elements, compounds, and mixtures. Elements, compounds, and mixtures. So mixtures are a combination. Now don't confuse it with compounds of two or more substances that are not chemically together. Now let me be clear. Azim, Pamuk, Baikal, listen carefully. They're not chemically together. So compounds, remember, are together chemically. Compounds are together chemically, but mixtures are not together chemically. So do you think I can separate mixtures physically, yes or no? Can I separate mixtures physically, yes or no? Anyone? Anyone? Compounds come together. Who said yes? Who said no? Sorry, I missed it. Who said that? Go on, have a go. So here's the real question. Compounds I cannot separate physically because they are together chemically. Yes, they are together, they are bonded together. But can I separate mixtures physically? Now, mixtures are not together chemically. So can I, yes or no?
Yes.
Azim say yes. Pamuk, what do you say?
Yes.
Okay, Baikor, what do you say?
Yes.
Tonruk, what do you say?
Yes.
Yes. Let me ask Tom Tam, what do you think? Can I separate mixtures physically, yes or no? Tom Tam, are you there? Okay. Kuming, what do you think, yes or no?
I think yes.
Okay, it's good. Nice panda work. Yeah, very good panda work there. Okay. Yes, they can be separated physically. They can. So a good example would be a salad. A salad is made up of different substances and salads we can separate. We can take out the tomato, we can take out the onion, we can take out the lettuce, we can take out whatever is in that salad because they're not held together by physical forces, by substances held together by physical forces, not chemical. So no chemical change is taking place. So we're going to watch a video now about types of mixtures. So I want you to listen to the video very carefully. I'll only play it the one time. So listen very carefully and these two boys will explain what we're trying to get at here. Let's have a listen. Let's see if we can play it first. Okay.
Mixtures. Chicken soup, clouds, cookie dough, mud, cereal, gasoline, blood, coffee, concrete, sand, your favorite soft drink, even the air you breathe.
Mixtures are a combination of two or more substances that do not undergo chemical reaction. Mixtures can be a combination of solids, liquids, and gases.
Italian salad dressing, for example, is a mixture of all three.
You can see the herbs, the solids, and the air bubbles, the gas, mixed in with the oil and vinegar, the liquids.
The components of mixtures can be separated through evaporation, through gravity, or through other mechanical means. Mechanical methods of separation can be as simple as picking olives off of a salad, using a filter to clean the air,
or using a magnet to separate iron filings from sand. Some mixtures can be separated utilizing specialized equipment. For example, a washing machine removes water from its load by spinning. Similarly, a centrifuge forces denser substances to the bottom by spinning a sample very quickly.
There are two kinds of mixtures, homogeneous and heterogeneous. These names are based on the Greek root words, homo meaning same, and heteros meaning different. The components of homogeneous mixture.
Okay, I know it's lagging, but I want you to be aware of these two words, homogeneous and heterogeneous. These are going to be important words in this topic as we move forward. And we'll practice these in a moment, but just listen to what I'm saying here. Homogeneous, heterogeneous. And homo means the same, hetero means different. But let's continue with this video.
Mixtures are uniformly distributed, whereas the components of heterogeneous mixtures are not.
Mixtures like oil and water, cereal and milk, and salads are called heterogeneous mixtures. The components in heterogeneous mixtures are unevenly distributed. Components may be as large as lettuce leaves in a salad, or as small as water molecules in an oil and water mixture.
One example of a heterogeneous mixture is when we put food coloring in mineral oil. The food coloring remains in the form of droplets that settle to the bottom of the container. The two components are not distributed evenly and make a heterogeneous mixture.
There are many different kinds of heterogeneous mixtures, including suspensions, which are solid particles in gas or in a liquid that settle out due to gravity, like sand and water. Another kind of heterogeneous mixture is an emulsion, which is a combination of two different liquids that separate out from one another, like oil and water.
Homogeneous mixtures, on the other hand, have an even distribution of substances throughout. Everyday examples include coffee, salt water, and homogenized milk.
The substances in a homogeneous mixture tend to have smaller particle sizes than in a heterogeneous mixture. In some cases, the particle size is too small to be distinguished from the other substances. Notice how the food dye distributes evenly throughout the water, forming a homogeneous mixture.
The food coloring cannot be distinguished from the water in the same way that dissolved sugar cannot be distinguished from coffee. Although they cannot be seen, both substances are still in the mixture.
There are many different kinds of homogeneous mixtures, including solutions and colloids. A solution is a homogeneous mixture whose components form a single phase. In the case of sugar and water, you can have a solid dissolved in liquid, but the outcome is a single-phase liquid. Colloids are mixtures where fine particles are dispersed throughout another substance and tend to have a cloudy appearance, like milk.
To recap, a mixture contains two or more substances that are held together by physical forces and do not create a new substance. Mixtures can...
Okay, so that part is important, remember. So we know, we've heard the words homogeneous, we've heard the word heterogeneous. Homo means the same or even, and we've heard the word heterogeneous. Hetero means separate or different. So here, as it says here, mixtures, two or more substances held together by physical force. So for example, sand and iron filing, bits of iron, are held together by physical force, usually by gravity, because we can separate them out. But if I get a magnet, I can separate out the iron from the sand by putting a magnet over the top. But more importantly, mixtures do not make a new substance. So for example, if I were to put together oxygen and hydrogen, if they remain separate, then that would be a mixture. But if I put together hydrogen and oxygen, but they make water, then it is a new substance, and that would be a compound. So mixtures are substances that do not make a new thing. They remain separate. They are separate things. And we can decide then whether they are heterogeneous or homogeneous. Let me continue with this.
It consists of any combination of solids, liquids, and gases.
Mixtures can be separated by many approaches, such as evaporation, gravity, or mechanical means.
Mixtures can be heterogeneous or homogeneous. The components in heterogeneous mixtures are unevenly distributed, whereas homogeneous mixtures are evenly distributed.
Okay, so this part is important again, so make sure you pay attention to this, please, everybody. Azim, you could focus. Thank you. So mixtures can be homogeneous or heterogeneous. Homogeneous, heterogeneous. Now I'd like you all to practice just this word with me. Listen carefully. Homogeneous. Homogeneous. Nang Song Sam?
Homogeneous.
Homogeneous. Very good. Well done. One more time. Listen to me carefully first. Homogeneous. 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 Nang Song Sam?
Homogeneous.
Very good.
Homogeneous.
And the next word is hetero. Listen carefully. Hetero. Heterogeneous. Heterogeneous. Nang Song Sam?
Heterogeneous.
Okay. Very good. Okay. So now we know that when we have mixtures, mixtures can be homogeneous or heterogeneous. Homogeneous means that it mixes very well and it's even. You can't see the different parts. So if I put sugar in water or if I put salt in water, that would be homogeneous because I can't see the salt and I can't see the water differently. But heterogeneous is when I have like oil and water. You can see here in this diagram that the oil, the green oil, doesn't mix with the water very easily. I can see where the oil is and I can see where the water is. So that is heterogeneous.
So now you know.
So now you know. Yes, you do. Okay, so mixtures can be homogeneous, and a good example is when you have a soft drink, or they can be heterogeneous, and a good example, for example, would be water and sand. Here you can see the sand is not mixing with the water, and all the sand is at the bottom. It's not separated through the water. But this juice, this lemon juice, is water plus lemon. And the lemon has gone all through the water. So that's homogeneous. I can see that the lemon has gone everywhere in the water. But the sand here, the sand has not here. Lemon does, moves everywhere, but sand does not. Sand just sinks to the bottom. It's in the water, but it's not mixing everywhere. It's not mixing anywhere. So it's going to be heterogeneous. Another example, though, of homogeneous is when I use water plus salt. So when I mix salt and water together, the salt mixes everywhere in the water. And I can't see the salt from the water. So it's homogeneous. And heterogeneous, as we just saw, is water and sand. The sand will go into the water, and even maybe some fine bits of sand, some fine particles of sand will move around the water, but most of it sits at the bottom. It's heterogeneous. I can see the water and I can see the sand. It's very easy. Okay, so now we're going to do a quick quiz. So I want everybody to message me. Just let me get my messaging up because I'm going to ask you to text me the answers. Pamuk, I got it now. Well done. Thank you, Pamuk. So I'm going to ask you a quiz now. So like before, I'd like you to type in your class number, and give me the answer A, B, or C. So remember your class, P6-1, for example, your class number, let's say 15, and then A, B, or C? A, B, or C? So the first question I'm going to ask you is, I'm going to show you some pictures. First, let's review. Before we do that, let's quickly review. An element is just one type of atom. An element is just one type of atom. So, Gun, can you give me an example of an element? Okay, what about Kuming? Can you give me one example of an element? I'll come to you in a moment, Gatsin. Okay, Pamuk, can you give me one example of an element?
Helium.
Helium. Azim, what about you? Can you give me one example of an element?
Xenon.
Xenon, very good. Can anybody else give me one example of an element? Anyone else on the call? It's okay, Pamuk, I've already had you. Gun, what do you say?
Carbon.
Carbon, very good answer, well done. By Core, come on, I know you know. Give me one example of an element. Come on, by Core. One pure substance, I know you know. Anybody else can give me one example? Ion, what about you? I don't want to do another one with you, Gun. I'll come back. I'm on to a different student. Okay, now remember, well, we'll come to that later. A compound has two or more different atoms together. So a compound has two or more different atoms. Who can give me an example? Thank you, Fit. Who can give me an example of a compound? Pitt, can you give me an example of a compound? Two elements together. Can you give me an example of a compound? Yes or no? What do you say? Have a go. Anybody else on the call? Who can give me an example of a compound? Azim, what do you say?
Water.
Say again?
Water.
Water, yes, water. Water has hydrogen and oxygen. There's an example of a compound. Hydrogen is one element, oxygen is another element. They come together and they make a compound called water. Anybody else got another example of a compound? Anyone else? Pamela, what do you say?
Methane.
Somebody, before you do, Pamuk, somebody said carbon dioxide. Who was that? I heard someone's voice say carbon dioxide. I missed who it was then. Okay. Shampoo. What do you say? Give me an example of a compound.
Carbon dioxide.
Carbon dioxide. Shampoo, you are a genius. Well done. Very good. Carbon dioxide. Carbon plus oxygen together, well, two oxygens, make carbon dioxide. Pamuk, you're going to give me another compound, yes?
Methane.
Methane. Very good. Methane. Carbon and hydrogen come together to make methane. Very good. Well done. Shampoo, do you have another one? Really?
Chlorine.
Chlorine. No, in this case, Shampoo, chlorine is an element because it's just chlorine. So that's not a compound. But if you added sodium, it would make sodium chloride. That would make salt. Okay. Shampoo, you need to turn your microphone off. Thank you. Okay, so there's our compounds. Now, mixtures. Who can tell me an example of a mixture? Anybody give me an example of a mixture? I guess Azim, as always, first hand. What's an example of a mixture, Azim? Any mixture. Anybody else? Shampoo, what's a good... Sorry? Salad, yes, a salad. A salad is a good example of a mixture. It has tomato, lettuce. Sorry, Shampoo, what do you say?
Sodium phosphate.
Sodium, what, sorry?
Sunfish.
Sodium sulfate.
Yes.
I think you might be right. I'm not quite sure what that is, but it sounds like a mixture to me. So I'll give you that. Well done, Shampoo. Very good answer. Okay. There are many mixtures. For example, if I put sand and salt together, if I was to put iron and cotton together, if I was to put mixtures of M&Ms and mixtures of chocolate, that would be examples of mixtures. And I can separate them with my hands, or knowing you lot, with your mouth, because you'll eat all those chocolates. Okay, we're coming on to the quiz. So I want you to answer A, B, or C. Now remember, you're going to text this to me, you're going to write this to me, messaging, put your class number, you put your class, P1, P6, 1, 6, 2, or 6, 3, put your class number, and then equals A, B, or C. Let's do this. An element, compound, or mixture. Rocks. Rocks are A, element, B, compound, C, mixture. Write your answer now. Message your answer to me now. Rocks. Element, compound, or mixture. You have 30 seconds starting now. 30 วินาที Fit, you seem to be talking. Rocks, A, B, or C. Are rocks elements, compounds, or mixtures? Which? Write your answer to me, please. Takun, thank you. Satara, thank you. Kajor, thank you. Month, thank you. Come on, Fit. I want to see your answer. Kuming, thank you. Jean, thank you. Come on, Shampoo. I think you know the answer. What is it? Tai Tai, thank you. Timothy, thank you. Namtam, Namtam, Timothy. Timothy, I keep forgetting about you, Timothy. Poi, Focus, Gun, by Core, thank you. Brilliant answers, well done. Most of you are saying C, some of you are saying A. Mostly between A and C. A and C. Ooh. Guitar, thank you. Okay. If you're wondering why I'm looking this way, it's because I have another screen over there and I can see you all on this other screen that I have because I'm working from home today. Pitch, thank you. Kalpan, thank you. Okay, I've got 2 more students missing. I need your answers, please. There we go. A, thank you. A, I forget about you too. 6-3. C. Okay, we'll come to the answers at the end of the quiz, but let's see. Next question. Copper. Copper. Is copper an element, a compound, or a mixture? A, B, or C? Write your answers now, please. Zenta. Who's Zenta? Zenta. Fit C. Fit says C. Pamuk. Pamuk, what was that? You got 1 to 6. Kalpan C. Shampoo A. Ploy C. Pixie. Waffle C. Fang C. Copper, element, compound, or mixture? Oof. I think you need to think carefully. Remember, copper, just copper. What is copper? Cat, Q.
ทองแดง
Tang, oh, thank you. Pambok, I haven't seen your answer yet, have I?
Yes, I answer yet.
Okay, thank you. A, by core A, Namtam A. Chain A, thank you, Chain. Okay, 2 more students missing. If you can, please. Okay, next question. Jelly beans. Jelly beans. Are jelly beans an element, compound, or mixture? Jelly beans. Element, compound, or mixture? Write your answer now, please. A, B, or C?
Teacher,
Yes.
jelly beans many color or
Yeah, many color. Yeah, don't worry about how they're made, but just the many color. Because they're made of the same material actually, but they're different colors. Elements, compounds, element, compound, or mixture. Thank you, Mon. A, thank you. Very good. Excellent. Thank you. Tankun, thank you. Timothy, thank you. Timothy, I'm going to call you more Timothy. I forget about you. C. Very good. Ing, thank you. Very good. Next question. 4. Element, compound, or mixture. Salt. Oh, sorry, sugar. Sugar. Element, compound, or mixture. This one's a little bit more difficult. Yes, Kuming, I can see you being afraid. Oh, no. Element, compound, or mixture. Playing, thank you. 30 seconds remaining. Element, compound, or mixture. Very good, Pick. Thank you, Pitch. Thank you. Amai, Fang, Kajol, thank you. Chompu, brilliant, thank you. Very good, okay. And I believe it's the last one. Next one, tea. Tea. Element, compound, or mixture. Let's assume that the tea has some milk inside as well, and sugar. If the tea has milk and sugar, is it an element, compound, or mixture? Thank you. Namtam, Center C, Tara C. Everyone saying C. B, who said B, Cartoon said B. Famai A, Jean A. Famai, I don't think it's A. Gun, thank you. All very good. Now you're all responding very quickly. Well done. Very, very good. And I think then we can look at some answers. Finally, salt. Salt. Is salt an element, compound, or mixture? Element is a salt. Salt is an element, compound, or mixture. A, B, C, or D. Good, Shampoo, thank you. Pat, thank you. Tara, thank you. Month, thank you. Okay, now you're all answering super quickly. Well done, very good. Month, thank you. Taimuk, stay, thank you. Thank you, Pig, thank you. Azim, I didn't see your answer yet, did I? Did I miss it? Kuming, Gun. Azim, what are you saying? Waffle, thank you. Fit, thank you. Ping, ping, thank you. Compound. Guitar, B. Grace, B. Nice, Grace, thank you. G. Timothy, focus. Azim, what are you saying? Where have we gone? Okay, let's look at some answers. Let's see what we've got for answers. Oh, neon, one more, sorry. Neon gas. Element, compound, or mixture. Neon gas. Neon gas. In B, Dumpy, Azim A, Nantam A, Month A, Fang A, Choktit A, and My Tandam A. Everyone's saying A. That's good. Good, good, good. Okay. Brian A, Jean, thank you, A. A question mark, you would have told me. Okay. And salad, the last one, salad. A, B, C, or D. Salad is element, compound, or mixture. Salad. What do you say? I see. Everybody's typing very quickly now. Well done, everybody. Very, very good. I like it. Nice. Everyone's saying C. A, very good. Cat, very good. Okay, now let's look at, and what about pure water? What do you think to that one? Pure water. Element, compound, or mixture. Chompu C. C. Azim, what's yours? Fit, Cartoon C. Remember, it's water. Is it held together chemically or physically? Cat, hi. Oops, she's not happy to be seen. Okay, Taku, B. Pamuk. Azim, Gun, I haven't seen your answers. Focus, C. Kuming, C. B. Namtan, C. Okay. Aluminium. I'm going to quickly go through the next one, 12 elements. Silver. Okay, let's go through. The answers are, we'll go through the first 6 answers we looked at, the first 6. The answer to question 1 is rocks are a mixture. Rocks are a mixture. So if you were correct, give yourself a nice tick. The second one, copper is an element, of course, because it's pure copper. Copper is an element. 3, Jelly beans. Well, very easy, I think. That was a mixture, so it should be very easy. Question 4. Table sugar is a compound because it's C12H22O11. Well, for example, it can be, if it was glucose, it'd be something else. But that's a complex sugar. So that's a compound. And number 5, tea is a mixture. Of course, tea is a mixture because it has milk, sugar, water, and tea. And the last one we looked at, sodium chloride is a compound. Okay, that should do us for today. It's been great. New topic. Monday we'll continue with this. And remember the key words. For now, everyone, have a great morning.